Hi, welcome back. So in the last session, we discussed about importing data in R, and we look at different options, how we can get around importing data if you have a CSV file, text file, and how the functions are out there. Those functions, how they can be modified, the default values can be changed so that we can import files or which has a different kind of separators rather than the default setting that we have for a particular function. So we looked into those ones. So we looked for the text files, we looked for the CSV files, and I think uh, there was one particular question was how do we import files if you're trying to use Excel files, how to import from the Excel files. So I'll start with that one and then we move into functions and iterations. So I'm just going to, I'm not going to have an exercise. I don't have an exercise to do it, but I'm just going to illustrate it on a piece of a paper. So the package that we need in order to import Excel data or Excel sheets is, the name of the package is called read Excel. Okay. If you're trying to install this particular package in your R environment, just simply you have to use the install .packages, and within the quotes you're going to put read Excel. Once this particular package is loaded, installed properly, you can load the package by saying library read Excel. Right. So basically then it has a function called read Excel that we can import in. So let's look at that one. So let's say we are importing the data and we want to store the data into a variable called data. You could call it as anything, data1, data2, df1, or whatever the name we would like to give it. We use a assigner arrow, and then we use the function called read Excel. So the function is read underscore Excel. Okay. And following that, we will have parentheses. Where in the parentheses, we specify it's few different attributes. So the first one we are going to specify, or the argument is going to be your file dot xls. This could be XLS, or you can have the file name of the file, whatever the file is, XLSX. Either of the formats work. Then we comma separated. The next one is sheet of your Excel file, which sheet you would like to import. So let's say if your Excel file has only one sheet, you possibly don't want to use the sheet argument. You just simply say read Excel and file.excel name and close the parentheses, and should be able to read that one single sheet that you have in read.excel. But if you have like multiple sheets in your Excel file, you can say sheet equals to, there are two different ways you can call the sheet. One is by the name. So you can give the name of the sheet, whatever the sheet is named as. If you don't have the name, then the sheets generally have numbers like sheet 1, sheet 2, sheet 3. So you can, that time you can do is sheet equals to 2. Let's say that's the name, the sheet with the name is number 2, then you possibly simply say sheet equals to 2. And then the final one argument, which I think is important to actually have an idea about, called NA. So if in your data is somehow some values are missing, then how those missing values are encoded. Sometimes they could be have a simply dot there, sometimes dash, sometimes it could have some digit numbers like 99, sometimes that value was used. So if you can specify how the missing values are coded in your Excel sheet, you can say NA equals to whatever. So let's say it's coded by dots. Then we're going to put quotes and then close the parenthesis. So it's going to be pretty much the same. So you're going to say NA equals to, in the quotes, dot. And so in this one, dot XLS, this XLSX sheet name, you can provide the name or you can provide the number. Here also you can provide the name or a number. Then you can specify how the missing values are there. If you don't have missing values, possibly you don't have to specify. You can close the parenthesis over here before the comma, and your function will run and read that particular sheet, whichever you are looking to import data from. All right. So this is the one of the, I think what we didn't talk about, or I basically didn't have any idea or have information on that particular function. So now we can import data even from Excel files. So today we are going to talk a bit about functions and iterations. So the functions is in some way, if you have already written a code to do certain kind of analysis and you want to use the same code again and again with a new data that is coming on, it so happens that every time you're getting a data, that data is in a very, very particular format, and you know, okay, this is a very standard analysis I'm going to do, so I can write down a whole function. And then what function does is take the data set and do a very standard operation based on what you have written inside your function and gives you the output. So you have, what you have is then is your self-contained a small function that does the analysis or does the calculations what you are intended to do on your input data and gives you the output. The function allows you to reuse the code again and again and again without actually rewriting it anytime. Iterations are, for sometimes you have, let's say, values, or you have data set which has n number of different entries, and each value you want to pick up and then want to do some sort of a calculation on it. So let's say I want to look at whether the number is odd and even. So I will check every time. So I will go value by value through my whole list or whatever the object I have. I will go by each element, do a particular operation, and then give you out gives an output. So that's the iteration process. So we will first start with functions, and maybe iterations we can discuss later. So the subsequent group, basically sessions, we will talk about group manipulations, and we'll finish by statistical graphing, generating statistical graphs using ggplot2. So that's what is intended. So here, if you look at, so let's say we have a n number of different vectors, and the vector has certain values. These could be some scores, could be gene enrichment, chromosome coordinates, or whatever the values are. But we have n number of different vectors, and what we are intended to do is to calculate the mean of each of these vectors. So if you do one at a time, the way you would be doing is first you calculate the sum of the first vector, find out how many elements are there in the first vector, and you divide the sum by the length, which is the number of elements, and you'll get an average or the mean of vector 1. Similarly, you're going to do for vector 2, vector 3, vector 4, and so on and so forth. And for the nth vector, till we run out, for basically finish analysis with all the vectors. Now, this is a very simplistic, you can say, problem of calculating mean, but you can think about it can become really complicated if you're trying to do standard deviations or some more complex analysis, and your line of code can run into like 30 or 40 lines. You don't want to write 30 and 40 lines for every single vector you come across. That's like not an efficient use of time and efficient use of computational powers, or not the computational powers, I would say efficient use of writing a code or of your time. So that's where the functions comes in play. So when you write a function is a self-contained object, or you can say self-contained code. In what you do is you name the function. So here, let's say for this vector, we are calculating the mean. We would call them as vector mean is the name of the function. And what is this function is going to work on? So like what arguments, what is going to take as an input data. So here we specify, let's say the input data is X. Now the X can be a vector, could be a data frame, depending upon the kind of code we are writing downstream. Based on that, X is going to be the input we will be providing. So here in this case, X is going to be a vector because we are calculating vector mean. So once you provided X is taken as an input data, and then we can write code that it calculates sum of X, then it calculates the length of X, and then it also calculates the vector mean, which is a vector sum divided by the vector length. And you'll get the vector mean. You can put a code saying print vector mean. And this is the way the output we can get from the function. Now, the X can be replaced by any of these vector names. So if we say vector mean X1 is going to calculate the vector mean of X1. If we say vector mean X2 is going to calculate the vector mean of X2. If you calculate another vector which has 1,000 elements, and if we say vector mean, and that particular vector is going to calculate vector of that particular one. So it doesn't differentiate basically what kind of vector is coming in, basically how many elements in the vector is, how big is a vector is, but it's going to be essentially, as long as the numeric vector is going to calculate a mean of it. And so using the same code, we can literally calculate mean across n number of different vectors or even more diverse kind of vectors. So this is the primary purpose of a function is, okay. Okay, we'll talk about that one in a while, but let's start with the vector mean. So before that, I'll just quickly what is the syntax to write a vector. So if you're anytime if you're trying to write a vector, it has a very simple syntax. The way we do is we use a function key called function. It's a function to write functions. And then within the parenthesis, we specify what's the argument, what kind of data or what kind of variable we are going to be providing to this function. Then we have curly brackets. Within the curly brackets, we have code to actually work on this particular data set. So this particular data set is taken into, it is analyzed or whatever, and then it gives you the output. But the general syntax is function, parenthesis, and then curly brackets. All the code is in the parenthesis, and then closing a parenthesis. Generally assign this creation of this function, assign a name to it. So we can give it, let's say f1 is our first function. So we can say f1 is a function which takes certain kind of data set and does certain some sort of analysis and gives us the output. So right now what we're going to look at is a scenario where we are going to write a code or a function which called vector mean, and which takes an input as a vector and then calculates the mean and gives us the output. So let's have a look at this particular code over here. So this is a pretty simple one. So let me, maybe it's difficult to write over there. It's okay. So vector mean is I'm basically creating a function whose name is vector mean. Then I'm using the function to initiate writing a function. This is going to be the input. X is going to be the input or the arguments that I'm going to provide for the function. And this curly bracket is the start of my code. So within this, I'm going to take this X and do some sort of manipulation on it. So what I'm doing here is within this one is, so this curly bracket can be spread across multiple lines. As long as you have an opening bracket and you have the corresponding closing bracket, you are good. It doesn't matter how far down this closing bracket is. So what we're doing is vector sum. We're calculating the sum of all the elements into the vector X, which is provided as an input. Then we are calculating the length of, length is like how many elements do you have, we have in that particular vector. So we use the function called length X, and it's going to provide the number of elements. And then we calculate the mean out, which is the mean calculated, which is vector sum divided by the vector length. This gives the average, and we were going to say print mean out. So that's the simple function is. So if we let's execute this particular function, and let's say so in order to execute this particular function, we need to have some sort of a vector. So let me create one particular simple vector of some numeric values. So I'm going to calculate 23, 33, 90, 20, 34, 67, and maybe 12. So x1 is a vector of all these different kind of elements. So before that, I wrote a vector mean. I wrote a function called vector mean, and that takes an input x. So when I'm going to call the function vector mean, I'm going to say vector mean, and immediately the system recognizes that the vector mean is a function. So it's going to provide you this parenthesis. Inside this parenthesis, you have to specify the x. And in x, in this case, is this particular vector x1. So I can simply say run x1. And what basically I'm trying to do is running the function vector mean and giving the argument or giving the input, giving x1 as the input. And so it's going to run over there, run over the code, calculate the sum, calculate the length, and then calculate the mean, and finally prints out the mean out. So it's going to print out over there. One important thing, or possibly I might have mentioned during when we are talking about right in the beginning, when we're talking about global environments and local environments. So these functions have something called the local environment. An environment exists while the function is getting executed, But the moment the function finished doing its job, all that environment just disappears, or you can say sort of erased. Now, what do I mean by that? So you can see that in this particular function, we created variables called vector sum. We also created a variable vector length, mean out, and everything. So if you want to call, I want to see, okay, what is the vector sum? What's the sum of all the elements is? So let's try using vector sum. Right? So the same, so S is kept true. And if I run that one, it just says that the vector sum is not found. So it cannot identify, doesn't know, or basically the system cannot identify where the vector sum variable is and holding the value. And the same thing basically holds true if you're trying to look for vector length. That is also not found. Even the mean out is going to have the same, and these objects are not found. So what happened? We did calculate the mean. So I think all this gets created, but what happens once? So what generally happens in this scenario is when the function was running, when it has a input, when it was calculating, all these variables exist. It created a small environment, stored all the values, and the moment the function completed by printing out the mean out, it erased everything off. So that's literally is disappeared. So you cannot retrieve what is there inside the function unless you explicitly tell it to return it. Return it in sense, the idea of the function return is that, okay, when the function completes, I'm trying to shut it down before it actually deletes the environment, give me all these values which I'm interested into. So we can have that one sort of like added in our code, and we'll see an example of that particular one. So this is pretty much the same. I don't think there's a so here in this case, what I did was I printed out the mean out, but you can also get the same value by a function called return. What it basically means, before closing the function, return me the mean out, return me the mean out variable, and the mean out variable is nothing but the mean of the vector we are providing. So let's say, and this is another vector I have created. Okay. And we have a vector called ages. So we have ages of, I think, 5 or 6 different individuals. And we were going to use the vector mean to calculate their ages. So we say vector mean and ages, is going to calculate the vector mean, give you the ages. So this time we are not using the print command, but what we are reusing is a return command. So this is typically, if you're trying to get something out of a function, you always use a return command. So the return is going to return all the variables or whatever you're looking that has been created inside the function will be returned to you or available to you when you actually execute that particular function. Okay. So what if you would like to have multiple elements? So we will look into one of the examples of that one just in a while. So this was a very simple one. Let's have a look at basically another function. And this function is called print name. So when we are running this function, we provide first and last, essentially the first name and the last name of individual. And what the function does, so again, we are using the same syntax. Okay, we are using the function, and inside the parentheses, we are specifying the variables. We can specify our arguments. We are specifying arguments. And these arguments can be as many numbers as possible. Can be 10, can be 20, depends upon the way you're writing function. There is no limitation to it. Then we are using curly brackets inside which we are going to take these arguments and going to do some sort of like say execution of some code on that. What we are doing here is we are printing out, what we are printing out is print first name. Forget about paste right now. We may discuss about paste at some point of time, but what we are printing out is we are printing out first name, colon, and then we print out the first argument, which is the first name, and second name, colon, and then print out the last, you can say, argument in the function, which is the second element over here. And so it's going to print out the names of the individual in a little bit different way. So let's have a look at that one. So let me create the function first. So I created the function. And now let me try, if I execute this function, which is print name by two different arguments, what output do I end up getting? So the second, what I'm executing is print name, it's the name of the function. And in the parentheses, I'm going to supply all those, basically supply the arguments. So let's see. It says print name. So we provide Mac and Anderson. So it printed out first name, so first name colon Mac, second name colon Anderson. So it just split them out and put some extra, you can say sort of like a syntax to it, extra text to it, and then printed it out on your on our screen. So we have provided two different, in a way, two different arguments in our print name function. What happens if you just end up providing only for, let's say, some we are have like thousands of customers and we are trying to print their names in the same way, but it so happened that one of the customers did not provide both first and the last name. We only have the first name. So let's use the Mac. So here's the Mac is the, let's say the individual only provide the name as Mac. Now if you run this particular function, the function is going to throw us an error. It's going to tell us, okay, the function was expecting two arguments, but for some reason, the second argument is not available right now. So that's basically is, in a way, if you think about, that's a collapse of the function in general. The function is no longer working on that particular. So how to come around that particular issue? So what we do in those scenarios is, if we provide what we call as a default values. So those values are held without, if you don't provide anything, the default values are always provided to the argument. So that's what we're going, this is the code for just setting up a default arguments. So the function which we created before, which is like first comma last, is the whole function is exactly the same. The only thing what we have done here is, in the front of first, we said equals to within the quotes NA, not available, comma last equals to again quotes NA. So when we are running the function, by default, the values of the first will be NA and the last will be also NA. If you don't provide anything, the function will still run and it is going to report NA at both locations. So let's try this particular function and see how does it work. So print name. Okay, so this particular function, I am not providing any names. So it's going to say first name is NA, last name is NA, which basically is not available. And now if I only provide only one name, so let's say I'm going to provide Andrew. I don't know the surname, so I'm going to provide Andrew. The function is not going to collapse. So basically error out is going to still print out the message. The only thing is going to tell you that the last name is not provided. Let's say the last name of Andrew is some name, something. What? Peterson. Okay, let's say. That's the second name of the. So this time we have the second name, but there's a problem now. We provide one name. It actually takes that first, whatever the name we provide, rather than taking it as a second name, it has actually taken it as the first name. All right. Why it happens is because here the first is in, when you write the function, when you're providing the argument, the first argument is first and the second argument is last. When we are providing the arguments, when we are running the function, it always, the first argument corresponds to always the first value, second argument corresponds to the second value in the, when we are running the function. So here, when we're running this particular function over here, we provided only one argument, which was Peterson. So there was the first value. The first value is corresponds to the first, or only one value, or the element one corresponds to first. There is no way for it to know whether it's a surname or it's a first name. So that's a bit of a problem. So there are ways to get around that one. So let's say if we put a comma in the front of it, which essentially tells it that there should be some value before comma, but that's not provided. And now we have Peterson. Now it's going to work exactly fine. So there was supposed to be a value here. So it takes, okay, the first element is missing. So that basically means first name is missing, but the second element is Peterson and it assigns that to Peterson. So this is the another way of doing it. even more explicit way of doing it is actually doing something in this way. You say print name, and you say first equals to Mac and last equals to Anderson. Now, if you execute this function, is going to it exactly knows that the first is Mac and the last is Anderson. Even if you swap the positions around, like you say last equals to Anderson, first equals to Mac, it still is going to print exactly the same way. So NA becomes the default values. So when we wrote the function, we provided NA as a default value. But once when we start executing the function, the values we will provide start overwriting the default values. So that's what happens, and the NA is no longer considered unless you don't provide one of those particular values. Okay. Yeah, you can also this we have, I think, seen an example where it's I think yeah, this we have seen discussed about why Anderson is considered as the first name, because it's the only value. You can, if you have only one value, you can simply say print name last equals to Anderson, then it runs perfectly fine, because then you're assigning that last, the value against last is Anderson. So then it takes, okay, that's the second name going to be. And this is quite useful. So for example, let's have a look at a function, help file of read.csv. Okay. We have talked about this function before. Now, whether it's a read.table or read.csv, if you think it doesn't matter. Generally, in most of the functions what we used in R have all of them, most of them have the default value already set. The primary reason the default values are set, because if you don't have default values and the user don't end up providing it, the function is going to collapse. The function is going to error out. Thus, you can say sometimes can be very difficult for a new user to identify, okay, what's going on. So what they do is they by default provide some, you can say, argument values. So for example, read.table is a function which reads some file. So the file is our first object. This is the first value that we put in. Then everything after that is header equals to false, separator equals to, in this case, it's not specified, and other values are over there. Now, if we don't have, let's say, if we don't have these default values and we have comma separated, then the read.table will expect that the first argument has to be file name, second argument has to be whether the file has a header or not, and the third argument has to be what is the separator of the file is. Now, if the user messed around those ones, that's a problem. Then the function is not going to work. So whenever you're trying to write, going to use this particular function read.table, the way we are using is read.table, name of the file, comma, header equals to true, and separator equals to whatever the separator is. Now, even if we swap around the location of separator and header, it doesn't matter. The function will still work because we explicitly told the arguments that separator value is this and header value is true or false, right? So that's why the default values are really crucial. And people generally, when you write a function, it's a good idea to provide certain default values so that if your function doesn't collapse at the but you need to be aware of the part as if it is your own function, that what kind of default variables you have set, and does it suits the current data input you're providing to the function. Okay. So any questions? Just feel free to put in a chat or just ask a question if just something doesn't make sense. These are so the functions are going to be really crucial if you're trying to do any kind of analysis. You'll be writing them to a whole series of manipulations on your input table, standardizing or replacing values, or all sort of those kind of things, or maybe some advanced analytics as well. And most of the packages what we use has functions inside them. So it's a good idea to understand like how the functions work. So you can also call functions by using a function called do.call. So you say do.call, you provide parentheses, you provide the function you want to execute. So we want to execute the function print name, and then we provide arguments, and the arguments we are going to provide is in the form of a list. We talk about what the lists are. So in the list, you can provide John, first equals to John, last equals to McEnroe. Why is it a list? Because the input arguments could be numbers, could be logicals, could be a table, and could be anything. So the only way to meet all those criteria is that the only, you can say, data object that can hold multiple object types is the best one is the list one. So you provide them in the form of a list. So when the function runs, it decodes everything and provide these variable names to the function print name, and it's going to work it. So if you execute this, it's pretty much going to do the same way what it was doing before, but we are calling the function a little bit differently over here. All right. So the next thing is, so going back to the calculating vector mean. So I'm just going to execute this function just in case. It's a little bit different than the other one. So this is, okay, whatever, wrong line. Okay, I'm creating a function here called vector mean, and the purpose of that one is the same what we have been doing before. Like we provide a vector of numeric values. The function takes those numeric values, calculates sum, find the number of elements, divide, and prints out the mean of the values. So let's say we execute this one. And as I mentioned before, none of the other variables that get created are basically reported here. So if it's a vector sum, which was created in the function, is lost. Vector length is also lost because those are variables that are created when the function environment existed. And the moment the function environment disappeared, those variables also got erased off, so we can't access it. But let's say for some purpose we want to keep track of the vector sum. We want to also know how many elements were there, and we want all those things to be output. So the way to do that one is to create a list of all the different elements or all the different variables that are inside the function that we want to be reported back, and then use return function to get them back. So is this one is pretty much the same function as what we have looked before. What only we are doing here is return, and inside the return we're creating a list. So we're providing the name. Sum is going to be vector sum, length is going to be length, vector length, and mean is going to be mean out. So there's going to be a list holding all these three elements. Now, again, as I said before, why it generally we request as a list is primarily because this data set could be of different types. So inside this one, you may have a single integer value, you maybe have a small data set which you want to report it back. So list is the best, you can say, object that can hold multiple data types. So we return it as a list. So I'm going to create this same vector function, but this time what I'm reporting back is a list of all these different elements that are, or basically different variables that I have created in the form of a list. Now, if I run age as here, and so this is like creating basically a vector called ages. Now I'm going to run vector mean on ages and store the output in X. Okay, and now if I look at X, I can simply say class of X is a list, and what a list holds. X holds the first one, the first value in X, what it holds is the sum. If you remember, the first value is sum, which is vector sum, so that is 177. Second value is length, so that's the dollar length, and that's value is 6. And then is the mean, and that's the dollar mean, and 29.5. That's the mean output is. If you remember, when we discussing about lists, we talked about how to subset or pick up elements of a list using $sign, using double square brackets, and using single square brackets, and what are the differences between those are. So if right now this doesn't make sense, why is it in this particular format, I would say just revisit our notes on lists, and this is the typical way of a list is being created, and the output a list is displayed. So yeah, we can go back and have a look at those, and then possibly these things will start making sense. Right. So you can call so then you can call individual elements also x dollar sum, x dollar length, x dollar mean. So this is the sum. This length is the number of elements. There were 6 edges in here, and the mean is 29.5. So that's a really basic, I would say, an introduction on what functions would look like and why, what is the general syntax is, and what the purpose of and how what the purpose of a function is. We want to use the same code across and different inputs, and don't want to write for everyone a different one. So we can keep on reusing the code again and again. Now, and one important thing is to, when you're returning the elements back, it's important whether you are returning a single element or you're returning multiple ones. If you're returning multiple elements outside of a function, you have to return them in the form of a list. Okay, so hopefully that explains. Any questions with any part of what we discussed so far? Okay. If you don't have any questions, then I will go to the little bit of the presentation side. So this is again just to highlight that how to get multiple values from the vector. The next thing which we're going to talk about is control of control statements. The control statements, or you can say the logical control, logical flow of instructions, is quite crucial, because sometimes you possibly may have to decide based on what value you got. Based on, you may have to decide one kind of analysis, or where you have to do the other kind of analysis, maybe sometimes within the functions or sometimes outside the function. It could happen both ways. So those are called logical, you can say logical tests. We end up doing it, and I will talk about if else kind of logical test, just to get an idea on that before we start using them. So before going in any deeper, I'll just give a quick, basically, the logical tests, what we have in case of R and if. Once I am going to I'll explain basically what those ones are. Okay. Should I go to the code, or should I go to be better? Okay. All right. But basically, I'll go to the slide first, and then I'll go to the piece of the paper, and then I may have some more explanations over there. So, okay, so let's say we have a scenario, and we have been approached by a bank for their ATM machine to start writing a code so that so when a person makes a withdrawal, we provide an instructions whether how much money has been withdrawn, and keep a balance of what's left and all those kind of things. And people make deposits, and we update their balance. So that's the kind of function we would like to write. Okay. So let's say CB is the current balance. So then once we write this particular function, then it doesn't matter even if the bank has 1,000 customers, we can use exactly the same function to provide the same information. So CB is the current balance, let's say that's X. DP is the deposit the individual is making. D is the withdrawal. So X is the current balance, Y is the deposit, and Z is the withdrawal. So once you make a deposit, let's say he's making a deposit of Y, then your new balance, which is NB, is going to be X plus Y. So that's your balance. And then WD equals to Z. Now, we don't know whether an individual, beforehand, we don't know whether an individual is going to make a deposit or going to make a withdrawal, or maybe first doing with deposit and then making a withdrawal. Could be both. So in that scenario, so we know that the new balance is X plus Y. It's original current balance, which is the original balance, plus what he had deposited, become X plus Y. Okay. Now, what we're going to check is when if let's say he's making certain withdrawals, then the first thing we're going to check is NB minus Z, his new balance, and the money he's withdrawing. So is he withdrawing more money than what he has? So that's what we are testing here. So we are checking if NB minus Z is less than 0. And that is only going to become less than 0 if Z is larger than NB. If Z is withdrawal, if withdrawal is larger than his new balance. So basically, he doesn't have enough funds into the account to make a withdrawal, so the value becomes negative. So in that case, this statement holds true. So what happens if it holds true? We are going to go this particular flow path. We will say print. Then we're going to just say, okay, print insufficient funds on the screen and tell him, okay, his new balance is this one. So, and then you say your new account balance is NB1 and in dollars, okay? So let's say the individual is withdrawing less than what he or has in account, then basically, let's say this value is going to be a positive number. This is not going to be less than 0. So it's not less than 0. Basically, this is false statement. So we start following the false path. And then we'll say, okay, print transaction successful, and your new balance, which is NB1, is equal to NB minus Z. So whatever is left out after withdrawal. And we again put new account balance is NB1. So in both the cases, we created NB1 and that is getting printed. And then stop the loop. So basically the transaction is completed and everything is happened. So this is what it, in a very simplistic term, this is an if loop, okay? But there could be multiple things we would like to test occasionally, and then how do we go about that one? So that I'm going to go on a piece of a paper, and hopefully that will be a little bit more clear before we go a little bit more in deeper in that. So in R, these statements, the logical testing statements, the if statements are, if you come across, are of 3 different types. One is you will come across if, or and then you're also going to come across called else if. There's a space between them. And then is going to be the else statement. Thank you. And so why we need else if? So let's take a very simple example. And let's say we are going to write a function which is going to tell us if the given number x is a odd number or as an even number. Okay, that's the kind of approach we want to do it. So the first thing we are going to test is if we're going to do a testing. So the testing we're going to do in the parenthesis. So we're going to say if x divided by 2 equals 0, and basically this statement here, these 3 things together is like the give me the reminder when x is divided by 2. It's going to tell me when the number is divided by 2, what's the remainder is going to be. If the remainder is going to be 0, that basically means that number is completely divisible by 2, right? So in that case, we can say x is, or we can print x is even, right? And this particular statement, let's say, closes. Okay. Now, the next thing we want to test is, let's say we're going to put else and if, and we're going to this time test if x, when divided by 2, and when we are looking at the remainder, if it is equals to 1, okay. In that particular scenario, we want to print x is odd. And this parenthesis closed, and basically you can close here or you can close here, and I'm going to close down. And then finally, I'm going to say else. You can say number not identified, number not, a number in not in correct format. Okay, number not in correct format. And I'll explain what it is. Okay, so if you supply a number, let's say x value is 4. So if we go here, we divide 4 divided by 2, completely divisible, nothing is left as a remainder, is going to print x is an even, and the rest, nothing is going to work out. The moment one of the loops condition is satisfied, the path is it's no longer going to go down and is going to just exit out and print x, and then not going to test anything downstream after that one. So let's say we supply a number equals to 3. So it's going to test if when 3 divided by 2, we will get a remainder as 1. So this is a false statement, right? So this is, so once if it is become false, it's going to skip print x and going to check the next one, which is over else if, where it's going to check, is it the remainder equals to 1? Yes, the remainder is equal to 1. Once the remainder is equal to 1, then only the command within the curly brackets is going to execute it. Here also the same thing. When we have 4, these code inside the curly brackets is going to get executed only if this values, only if this holds true. When this holds true, then only we are going to enter this curly brackets. Otherwise, we are going to skip the curly brackets, go to the next one. We test here, this particular thing. If this holds true, then only we're going to go into the curly bracket, which is like printing out this statement. If this is not holds true, we skip that one and go to the last, basically go to the else statement or the next statement, whatever it is. Now, so in this, when we provided 3, that's fine. So it's 1 is printed as odd. People are very funny when if you're writing a code to be used by people, some people may end up providing all sort of data inside. So let's say somebody end up providing a complex number. Let's say 3 plus under root of -1 and 4. Now this is a complex number. When you start dividing by 2, this is not going to get satisfied. So you skip that one. You're going to get this one. This is not this is not satisfied. So it's going to skip that one also. So the else statement is when nothing else is going to work, print out this particular thing. So when none of the above statements holds true, in this particular scenario, is just simply going to say number not in correct format. So this message is particularly you have to decide based on what kind of function we are writing. Okay. Now, how many else ifs we can have? We can have as many else ifs as we want. Okay. We can, so generally our statement starts with if. We have testing condition, and if the testing condition satisfies, this is what we are going to be doing. If it is not, then we're checking the next thing, which is else if. Then if else if, again, we do some sort of a testing. If that condition is satisfied, we're going to execute the code in the parenthesis. Now we want to test one more condition, you can have else if again. And one more testing condition, you can have a loop, again closing again. And you want to have one more, you can have else if. And finally, you can have else. So else, and then you just simply close the parenthesis. So you can have as many different logical tests as you would like in here. So you can have 5, you can have 10, you can have 20, 100, whatever you would like to. And the only downside of having these many is it makes the code run a little bit slower. So generally, people don't tend to write too many else ifs, but 2 or 3 are okay. You can put it into your code. If you don't see any other alternative, you can do multiple testings of these ones. So for example, let's say you have a big genome enrichment file. And what you want to say is you want to isolate out all the chrome. There are different ways of better ways of doing it, but I'm just explaining a really simple example. Let's say I want to print out the coordinates for chromosome 1 and chromosome 2 and chromosome 3 separately. Then I will check here, is the chromosome is 1, then print out in this particular place. If chromosome number is 2, print out at this place, chromosome number 3, print out this place. Else, if it does not fall into 1, 2, 3, then print out some other place, or whatever the function we want to do it. The idea is like, this is how we do multiple, you can say sort of like logical testing before we decide which way, what we are going to do with the respect to the input data. Any questions with respect to what we looked at there? Okay, so let's look at a little bit more complex work. So this is again, so this, if you see the code on the right hand side, is the code to pretty much achieve what we are trying to do here. And here, so we have so we write a function, and the name of the function is client balance. Write a function, and we provide arguments. So the arguments are current balance is 0, deposit is 0, withdrawal is 0. So we want to have default values so that our function doesn't fail. And then we have these curly brackets. Basically, this one and this one is this is the opening of the function, and the last one is the closing of the function. So our function closes here. Now, inside that one, we are saying new balance. So the new balance is equals to current balance plus the deposit, right? So that's how it becomes new balance. So we satisfied this thing. Now we want to check this particular part. So we are doing if new balance minus withdrawal. So this has to do in the testing has to be done within the parenthesis. Okay. So this is the parenthesis where we are doing testing. And what we're doing is new balance minus withdrawal, new balance minus withdrawal. Is it less than 0? We are testing this one. If it is going to be true, then the code within this curly bracket and this curly bracket over here is going to get executed. So which basically means this is true. We have the individual has insufficient balance, and that's about it. So basically, that's whole true is going to say print insufficient balance. It's not even going to go further. After that, is going to just simply print, come out of this if loop, and going to say print your new account balance is so and so forth. Okay. Let's say that the other scenario is, yes, he has enough balance and he's withdrawing decent money. He's still left out with something. So in that case, the value is not less than 0. So this is not true. So it's not going to execute anything between this curly bracket and this curly bracket, but looks for the next testing or logical thing. So it's going to be the else. Else is something. So if this is true and false is something like else. So when if it or else, basically when it is false, new balance minus withdrawal. So new balance is basically updated after withdrawal, how much is left, and you say print his transaction is successful. So again, and then after that, we are just simply saying the same, that your new account balance is this, so and so forth. So this is a simplistic approach. Now we got away with if and else loop, saying that if the if statement holds true, we do one thing. Otherwise, we end up doing the second thing. Doesn't matter if whatever it is. But sometimes, let's say you want to be really customer friendly, your bank want to be really customer friendly. So you want to really polite to tell the customer that, okay, once the account balance reaches 0, just tell them, okay, your account balance is 0, you may need to put more funds or something like that. So now what we have to do, we have to add one more logical test to it. So let's see how then, so these are the two scenarios. These are basically running through the same, you can say, same basically flow chart using certain values. So you can see that in one case we are following true and reach here, and we are making overdraft or maybe over withdrawing like 400 when we have balance 220. Here we are withdrawing less than that, so we keep going straight, like the transaction is successful, and we end up telling them that, yeah, you can withdraw the money. Let's say that this is a scenario which I just mentioning about in a particular case when your bank want to be a little bit more customer oriented and want to tell them, okay, your balance is 0. So how do we get around that one? So we start with exactly the same parameters. So we say customer balance, deposits, and withdrawals. And new balance is the customer balance plus the original balance plus the deposits. And then the first thing we check again, is the individual withdrawing more than what he has in the account? So if that is the case, then we don't want to go any forward. We just want to we just want to stop any transactions and let the individual know that it has an insufficient funds and basically come down and stop it. But let's say that's not case. It's not less than 0. But then the two scenarios. One is it becomes 0, which is like equals to 0. In that scenario, the individual is withdrawn all his money. And the other scenario is he still left out something in the account. So the next thing what we're doing is we are testing using else if statement. So using else if statement, we are saying, does the NB minus Z is equals to 0? Yeah, it is. If it is equals to 0, then what you simply want to say, transaction is successful, your funds are 0, please add more funds. So you just want to add an agree. So this line is going to get executed only if this command holds true, or this testing holds true. Otherwise, it's going to go in the false loop. Otherwise, it's going to go through the false, and then it's going to print out the transaction was successful and you have enough funds. So this is your new balance, and so on and so forth. And that is a little complicated. We will possibly, so let me go through the code and let's have a look at it. Yeah. And essentially, it may look a little bit intimidating, but just sit and maybe I would recommend just sit and have a think about it, like what essentially is happening in this one. So the whole thing is just a function providing 3 different arguments for the function. And then we are using if statement. And the first thing we are testing is within this one, we are doing the first test, whether the new balance minus withdrawal is less than 0. If that holds true, then we are going to print between, we are going to execute the code between that and over this one. And once then we don't go any further down. That's where we stopped with respect to this if loop. So and we stop pretty much over here, and we go to the line over here. We don't go and check what happens to the else, because we already satisfied the true condition. Let's say if that holds false, then we don't even enter into this code loop at all. We go to the else part, and then we execute the remaining part of the code over here. And then we end up printing out whatever the balance is and return the balance as using the return statement, so that we can update that individual's account or so. These are different values we are feeding it for different individuals. So I think it's pretty much, so let's create this function first. So we created a client balance. So we execute it again so that we have it on the top of it. So now we are going to do client balance. He has original balance is 200. You make a deposit 20 and withdrawing only 10. So let's see what happens. So in that case, because it has his X is the current balance is 2000, that's 200, which is the first value. Deposit is 20, so his new balance becomes 20 plus 200 plus 20, so 220. So this output is 220. 220 minus withdrawal, which is 10, is only 210. So 210 is not less than 0, so we don't enter this loop at all. We directly go over here. And here what it says is print transaction is successful. So it printed out transaction is successful. And then it prints this message at the bottom, which is your new account balance is 210 US dollars. And then it prints out the new balance over here. So that's what essentially happened. So now let's try the next one. And in the next one, he has the individual or the possible customer has $200, make a deposit of 20, but trying to withdraw $1,000. So the new balance is 220. But when you subtract 1,000 from 220, you're going to get negative 780, which is less than 0. So immediately this becomes true. Once it becomes true, this code starts getting executed, and that's is like insufficient funds. So it's immediately going to tell you that it's insufficient funds, and this part is not even being entertained, or the code doesn't even go that far, because once the true statement has been pretty much here, like if you have become true, that is, you're not going to go through the false part. You become true, you follow a different path, and then you're going down to go all the way to stop. You're not even going in this direction at all. So that's what happens. That's why this doesn't even being entertained. And it says insufficient funds. And then it prints out the message that the new balance is 220 US dollars. All right. I think the last one is pretty much the same. This time we are not making any deposits, but again, you're withdrawing, the individual is withdrawing a lot more than he has in his account. And that's, you can see it says the insufficient balance, insufficient funds. We'll talk about a little bit more logical next time, but the one thing is, like, once the condition is satisfied, we take one route. We don't even think about what is happening on the other side. And that condition is satisfied, we come out of that if statement loop. So this is in a simplistic term, if you think about, this is an if loop, or sort of an if statement, which starts at here and closes it with this parenthesis. So in this one of these things will be followed, true or false, and this is outside the if, so it gets anyway followed like a regular code. I would stop here because I think we're already an hour in the almost close to finishing. But if you have any questions with what we have covered, I'm more than happy to answer any questions you have.